So, Asa, we're going to be talking today about design operation of effective exhaust systems for facilities that have finishing lines, those type of things, including scrubber maintenance. It seems like that's a very important aspect of all finishing operations is to have these controls in place, doesn't it?
Yes, absolutely. And of course, emission controls are not something that necessarily make money or optimize processes, but certainly it's something you need to take care of. And if it's done appropriately and well, then it minimizes downtime and can be better for your process overall. So usually one of the first things that we look at is, documentation on the original system design and optimization, and really going back to that to see what the design considerations were and the operational set points so that we can go through and see how the system in the current state deviates from the design parameters.
Right. Right. Yeah, it's funny. I just ran an article, I think maybe 2 weeks ago on it was air quality in finishing operations. And it was actually done in Russia, of all places. But the study actually mentioned that, those finishing operations that had, good air quality handling equipment and kept it up to date and those type of things really didn't have a problem with any type of issues with air quality. It seems like they did a very good job and that these pieces of equipment do work.
Yeah, absolutely. As you mentioned, it's not just from cleaning the air prior to atmospheric discharge, like you might get into a regulatory violation, but it's the indoor air quality and keeping employees happy and minimizing turnover and all that sort of stuff,
Right.
of course, has an underlying effect on optimizing your process.
Right. Yeah, definitely. So let's talk about a couple of questions I want to talk about. Appropriate gas velocities. How do you maintain those throughout the system? I'm sure there's, balances and such, but how's that maintained properly?
Sure. In terms of gas velocity, I mean, there's a few different areas of the system where you're going to be looking at the source capture. Let's say it's an open surface process tank for anodizing or pickling. You're going to be looking at slot velocity in the hood. So with respect to the hood design, you're going to be looking at duct velocity. Maintaining a minimum duct velocity to make sure that the contaminants are being transported effectively from the source to
Mhm.
the emission control device. And then finally, within that emission control device, whether it's a dust collection system or a wet scrubber system, maintaining velocity is going to have an effect on, the performance of that emission control system and whether or not it's operating within spec. And
Right.
generally, with respect to an air permit, those sorts of operating parameters, velocity, static pressure, that's going to be tied into the air permit as a pass fail, right? Versus doing an actual
Right.
continuous emissions monitoring on the outlet. So really, in terms of transport velocity, it's throughout the system from the source through the exhaust stack.
Right. Right. Definitely. Yeah. And like you said, shops they do need to have really an effective source capture at the local exhaust through the ventilation. So tell us, how does that work? What's a properly designed system like that work?
Sure. In the sort of projects that most of the metal finishers are involved with, you're looking at, as you say, source capture, or usually called local exhaust ventilation, which is distinct from general exhaust ventilation, which would be more
Right.
typical of air changes per hour. So by capturing the contaminant at the source, again, if we use the process tank example, making sure that the hood configuration is correct for the size of the tank. As we know in metal finishing, you have all sorts of different sizes and configurations. It could be architectural anodizing with long extrusions. It could be small parts, and we also could have some obstructions with bus bars or whatever the racking setup is. So it's important to look at every process as unique and design ventilation appropriately around the process, looking at all those inputs.
Right. Yes, definitely. I know it's important to keep the ductwork clean. I know. Talk about the use of mist eliminators. How do those work in the hoods to keep those ductwork cleans with that?
Sure. It's very common for companies to look at sort of a two-phase or two-step emission control setup where you have a pre-filter, coalescing filter and a mist eliminator, as you described, at the source of contaminant. This is especially true in metal finishing operations because you don't have just the acid and alkali aerosols or mist, but oftentimes you have particulate matter, which from the surface treatment of the metal that makes its way into the system as well. So if you have a capture device at the hood that can take kind of the bulk of the contaminant before the duct system, before we even talk about getting into the rated emission control, that can be a huge maintenance saver as well.
Right. Right. One thing is to avoid, material fallout is the velocity in the ductwork has to be up to snuff. If not, you're going to have issues if the ductwork isn't really pushing it out properly. Correct?
Yeah, that is correct. I mean, there is a kind of common saying in this industry that is, if the velocity is not correct, that it's too low, your transport velocity, the ductwork will
Right.
narrow
Mm.
to the point where it gets to the proper velocity, just meaning that material fallout, is going to clog up the ductwork. So that is one of the most common things that we see with systems that are either older and or not kept up to within maintenance spec.
Right. Right. Definitely. Let's talk about a scrubbers for a bit. Blowdown rates. Tell me what that is, and what should shops know about those?
Sure. So wet scrubbers use water, fresh water, and then also there's obviously a wastewater stream, and everyone wants to save water, of course.
Hmm.
As you're adding caustic to a acid gas scrubber, there's a certain sort of purge stream that is specified based on the absorption. If you have a limited blowdown rate or it's below spec, at a certain point you will have caustic, which is most often sodium hydroxide solution that is used. Occasionally you'll have some potassium hydroxide spec, but you can have solids precipitating out, which leads to a fouled system. So really, blowdown rates, it's a trade-off between trying to minimize wastewater and freshwater usage, but there's a certain lower threshold where you can cause some pretty serious maintenance problems, which could lead to a shutdown.
Right. Right. Yeah. Something definitely paying attention to with that.
Sure.
Yeah. As I said, balance is important in saving, with fresh water and wastewater and the scrubber costs. So let's talk about that a little bit about making sure everything is balanced out with that.
Sure. In terms of scrubber costs, I mean, on the front end, if we know that, uh, the intent of the facility in terms of what are all the different operating conditions with respect to minimum and maximum airflows and different sorts of layout considerations. One thing that might be considered is accounting for future expansion with
Hmm.
respect to the exhaust rate. If you can oversize a system, let's say for a planned 20 or 30% airflow capacity,
Hmm.
and understand that down the line, that capacity could be very valuable, not just in terms of uh, future capital expenditures, but a
Right.
lot of these places, as we know, have very limited floor space. And
Right.
so if you're locked into, having the more permanent equipment accounted for on the front end, that can save you a lot of time and headache
Right.
in the future.
Right. So I guess you're saying to basically calculate in oversizing the system because you just don't know
Yeah.
what's going to be coming down. Though easier to do it now,
Another
probably
thing
more
to,
cost effective. Yeah.
yeah, another thing to mention, Tim, is that in the in the actual ventilation of the process tanks, a lot of times you can use a push assist or push pull ventilation,
Hmm.
which will significantly cut down on the exhaust rates that are required. So if that's something that is applicable to the process, that is certainly something we would consider.
Right. Definitely. Definitely. I was going to say that's something that you all do is you all are really paying very close attention to a lot of the new regulations that are not here today or not just here today, but also could be coming down the pike, right? Because these things seem to change a lot. Every couple years that might get a little tighter. And that's something really, a lot of shops probably are not paying that much attention to what some of these regulations are going to be, or what, like you said, when what they could be down the road, right? As far as anything else that might be coming as a regulation matter.
Yes, and Tri-Mer engages with regulatory bodies as on sort of a research basis independently.
Mm-hmm.
And so we are aware of regulations on the horizon and current regulations. Typically, in the US, everything starts with the West Coast in California with respect to,
Mm-hmm.
having more stringent regulations. And then things get sort of integrated into the rest of the country. It's also very dependent on industry and process. So metal finishing is regulated differently from an air emission standpoint than power generation, for example. So understanding not just the regulatory restrictions around specific compounds, like in terms of air permitting, but by industry is important as well,
Right,
because Trimer
right.
does quite a bit beyond just metal finishing.
Right, right. Do you all recommend? I mean, shops. How do they do it? Like an evaluation of how their equipment's running and whether they're meeting the guidelines and such. Do you ever? I mean, is there a recommendation that you all make to them that they do an annual, say, audit of their systems to see how it's working, or is that?
Sure, Trimer does perform quite a bit of service on our own equipment. Those
Mhm.
are, as you say, annually, and they are also as frequent as maybe say quarterly. That really depends on the specific company and what their staffing looks like. Some folks have the internal maintenance staff and know-how and experience to be able to service the equipment internally themselves. And then Trimer just can act, as offering replacement parts and service work as necessary. And then some companies, as maintenance staff has become kind of leaner and
Mm.
internal engineering has become leaner, throughout the industry, they rely on third-party system performance inspections, either performed by the supplier like Trimer, or there are companies that just specialize only in system maintenance.
Right, right, definitely, yeah. And like I said, the article I found it was quite interesting a couple of weeks ago. The article about air quality and those type of things. And like I said, the end result was it can be managed. It can be managed effectively, and as long as you're keeping the equipment up to date and keeping it running. And like you mentioned, it's good for the employees, good for the morale, good for them to as a working environment to keep it working effectively.
Yes, absolutely.
Yeah, great. All right. Well, thank you, Asa. I appreciate it. People can visit your website. I'll have it there on the screen, but I appreciate you taking time out for us.
Thank you, Tim.